Welcome to this second day of Intertraffic in the Rai in Amsterdam. We have our first speaker of today for you. Laurens is over there. And we have an audience live here in Amsterdam, but there's a camera behind us, behind you, and that, that's our audience from around the world. We have many visitors online as well. So these sessions here in Theatre 2 are all recorded for you and are available later on in the app. So just so you know. Laurens is a fourth-time speaker here at Intertraffic, and Laurens is from CGI, standing over there, and he's going to tell us about smart mobility in logistics. Let me see. One lady. Ladies and gentlemen, can I have an applause for Laurens Laprey? Laurens, welcome. I'm here over there with a microphone. If they have any questions, can they ask them?
Sure, of
yes?
course.
Okay,
Yes.
great. Take it away.
Okay, thanks. My name is Laurens Laprey. I'm a vice president by CGI. And having a runway is the first time for me, so I have to adapt a little to that format. I'm currently working as a program manager for Smartways. Smartways is a large-scale infrastructure and smart mobility project in the south of the Netherlands. And that project and program is all about keeping the south of the Netherlands accessible. And that's important for you too, because a lot of the goods which come in through the main ports, like Amsterdam, Rotterdam, Schiphol, and even Antwerpen, are distributed through the rest of Europe, through the south of the Netherlands. And in the south of the Netherlands, we have roads which now have a continuous lane of trucks on one side of them, and that cannot continue. So a lot of effort has been put on how can we make the south of the Netherlands logistically accessible to transport goods all over Europe. Now, CGI has been involved in that program for a number of years, and we've worked on a number of elements of the Smartways program. And I think Smartways is very interesting in the sense that it's both infrastructure, but it's also smart mobility. And it gives us a number of opportunities which are pretty unique. First of all, if you can use smart mobility services to redirect traffic, certain infrastructure measures might not be necessary. Secondly, if you are going to go with infrastructure measures and you have roadworks which have a lot of impact on traffic, you can use smart mobility to alleviate the pressure of roadworks, for instance, on certain transport streams. And lastly, in the Netherlands we have a lot of building going on, and there's a lot of nitrogen-related emission problems which might cause delay in a number of classical infrastructure projects, and there you can also see if smart mobility can give you a solution. And what I'm going to talk about is a number of services we have designed all around how can we use data within smart logistics. Now, if we look at the Smartways program, and you have here the most important elements of that program. These are the KPIs of that program. Now, Smartways as a program doesn't develop things themselves. We take existing national ITS projects and align them to the local regional agendas which we have in the south of the Netherlands. So we look at what is available nationally and internationally on one side, but we also look at the 7 regions within Smartways and how can we match these programs to their specific agenda. So if there's a city, for instance, who has a certain traffic load in their infrastructure caused by a distribution center, we can take a number of these national projects and see if we can use them to create more space for that. So a large part of it is how can we align these projects with the regional agendas. If you're interested to learn more about Smartways, you can see the link there online. You will find a lot of English information on all the different programs which are part of the Smartways agenda. Now, one of the things I specifically I'm working on is smart logistics. Smart logistics is built around 4 pillars when we take a look at it from the SmartWay side. 4 different elements of the program we are now building projects around. And you can see the different KPIs we are trying to reach with this program. So we're trying to get less traffic kilometers. We're trying to get less journeys when it comes to traffic. We're looking at how can we use the infrastructure in a more accessible way, how can we make freight traffic more safe, and how can we spread and optimize traffic. And to give you an example, if we look at efficient use for freight traffic, a lot of the optimization in logistics is looking at the delivery side of things. And one of the things we use in efficient use for traffic is we look at the order side of things. So instead of ordering your goods once every day, creating a traffic stream, it might be much more efficient to order your goods once a week and have much more optimization. So that part of the program looks at the front end of the logistic chain and see how we can change that using different order patterns. Adaptive use of infrastructure looks primarily at how can we use smart infrastructure services, all kinds of sensors, all kinds of data, to make traffic much more efficient for logistics once it gets on the road. Same goes for safe freight traffic. Safe projects are not only about safe. A lot of unplanned delays in logistic traffic comes from incidents. So if you can create less incidents, you can also make ETAs more reliable. You can make traffic on the road more efficient. And lastly, if we have traffic going into the city, can we redirect that traffic, for instance, using hubs and using other kinds of mechanisms to spread the traffic so to create less congestion. And for that we use a model based on how we look at the logistic patterns. On the left side you will typically find the corridor elements, like for instance the main ports, the terminals, and the large roads which we have in the south of the Netherlands. And a lot of effort is geared towards that side. How can we make transport from Rotterdam to the distribution centers in the Netherlands more efficient? But there's also a lot of interest in the right side of this picture. And that is where we get sustainable urbanization as a major element in these kinds of projects. And if we look at the traffic we have in our cities, we look, for instance, at traffic related to construction. A lot of the municipalities in the Netherlands are now working on generating more houses, which leads to much more construction traffic in inner cities. And how can we optimize that using all kinds of hub mechanisms? Same goes for retail, same goes for parcel delivery. So what we do from Smart Logistics is we look at the total chain of transport. On one side, the main ports, all the way through the city hubs to the delivery points, and see how we can use kinds of optimization for those kinds of elements. And in the blue, you can see a number of goals we are trying to reach. We are trying to make less trucks on the road. We're trying to make more efficient parking. We're trying to see if we can get less construction through the different parts of the city. And an important element of that has to do with data. What we discovered is that there is a lot more data available than actually being used to handle these type of projects and problems. And if we can connect data, we can make these elements more efficient. And we found that if you could connect data from the cargo side and the road and route side and the vehicle side together, those three, you can handle a lot of these problems in a more efficient manner. And in a moment I will give you an example of a service which is built around that concept. So the trick is, how can we, if we look at these different points in the logistic map, how can we get data from at least 3 origins together, cargo, road and vehicle, and to make these things more efficient. And there's a lot of data becoming more available. And in the Netherlands, specifically over the last 5 years, we had a number of large-scale projects all geared towards getting this data on roads out there and making it available for people to use. And what you see here is an inventarization from a couple of years back on the different data we now have on roadsides in the Netherlands and the way we can now cover the different elements we have in the roads. And what you will see when it comes to, for instance, static traffic signs, we pretty much have all of them. Dynamic messages, the same. Road elements. But if you look at data for logistics, you see that there's a gap there. And that is something we're working on currently, is how can we make all the data sources necessary for logistic planning also digital in a way that they can be incorporated in transport management systems or fleet management systems. Now we do that in a large part by looking at national projects. Smartways in itself doesn't develop. We take existing national ITS projects and align them with the local agendas of the 7 regions we have in the south of the Netherlands. And one of the projects we've been using a lot is what's called connected transport corridors. And that's a service why we bring the data from the different sources into the truck to generate more efficient traffic, to get the driver aware of safety issues which are coming. All kinds of services we can now build as part of these services. So what I'm going to do is I'm going to step through a number of these services to give you kind of idea on what can we now actually display in the truck when it comes to data, and how does that impact, for instance, the driver's behavior or things like planning. And for that I'm going to use this model, and here you have a connected transport corridor, a road which has all kinds of elements, dynamic traffic signs, static traffic signs, green light, intelligent traffic light controllers, sensor data. It's all generated in this road. And how does the truck now operate and interact with them? Now the first step we have is that essentially everything which is relevant for the truck, which is displayed over the road, can now also be displayed in the truck itself. Imagine that you drive along in your truck and you see these road signs, the dynamic signs on the top of the road. You will also see these signs on the display in your truck themselves. And you saw in the earlier picture that almost all dynamic road signs in the Netherlands are now digitized, which means that every information and all the information which is displayed on the top of the road, over the road in these signs, can now also be displayed in the truck. What is important is that we only display those elements which are relevant for you given your route. So instead of displaying everything which is available, we filter this information specifically for your route, and that is the information you get. And we see that is much more efficient towards the driver, since they only have to take a look at that specific element. The next things we do has to do with everything which is part of the road, like roadworks warnings, open bridges, accidents. All these information which can happen on trip are also displayed in the truck. Which means, for instance, that if an emergency vehicle is coming up behind you, you will get a signal in your truck that that is happening, and you can take that into account. All kinds of elements which come to have to do with truck parking, for instance, you will also get displayed within the car. And that means also, again, not all the information is displayed, only the information which is necessary for your specific route is displayed in the car. Well, a very important element is the intelligent traffic light controller. So some years ago in the Netherlands, we had a large-scale project which rolled out a lot of intelligent traffic light controllers within the different crossings we have. We have now more of 800 of these type of controllers, which are two-way communication with traffic lights, which means we can do things like green light priority. That means that if you approach a traffic light with a truck, the traffic light will try to stay green for you. In that case, you don't have to brake and accelerate again. That saves fuel and also saves transit time across the crossing. So what we see now is that using the same service, we have intelligent communication between the trucks driving on the road and the different elements on the side of the road, like traffic light controllers. And what you can see here on the left is the number of intelligent traffic light controllers which allow two-way communication in the central part of the Netherlands. And to the right you have an example of a city in the south of the Netherlands, and you can see that there are traffic light controllers on all the major crossings in the access routes to the city, which means that we can generate virtual green waves for trucks, allowing them much more easier access in and out of the city without disturbing all kinds of other traffic. And as an example, you can see here an application which is built by DINIC, which communicates with the traffic light controllers, and you will see per lane how long it will take for the traffic light to go on green. You can adapt your speed and you can save fuel by not having to brake and accelerate again. And this is one of the services which are very interesting for people who are into distribution of goods towards the cities, because they typically have all these traffic lights they have to wait and accelerate again, and that can be handled now in a much more efficient manner. And at this moment, some 30 companies are already using these services, and we have more than 800 traffic lights in the Netherlands which allow this two-way communication. Another important part is what we said earlier, is the data for logistics. So we not only look at on-trip information, what can we do during the trip, all kinds of safety elements and incidents. We also look what is necessary for the transport management system, what is necessary for transport planning. So there's also a lot of data which is available pre-trip, for instance, when you're making your route. And here you can see the different types of information which our municipalities are now making available, digital, which can directly feed into your transport management system. Which means that you now have, for instance, truck priority routes from municipalities, which you can use to plan. Or when we look at sustainability, low CO2 emission zones, you will have them in your transport management system and can use them when you're planning a route. Same goes for truck parking or forbidden zones. So the idea is to have all these mobility elements of a municipality become part of your transport management system, which means that during your planning phase you can take into account what this municipality wants and how they want the information and how they want their logistic patterns in the city to evolve. And we find that a lot of interest is in these kinds of information when it comes to transport management and comes to planning. And of course, if you would not have this information, you will have a lot of additional work you have to do, a lot of work by hand. And the idea is to have this kind of information available in a generic way for every city in the Netherlands. So you can tap in at a single point and get all this information independent on which city you're working on. Last element is that there are a lot of sensors now in the road, and we are working on making that sensor information also available within the truck itself. An example is we have here a truck riding over a tire pressure sensor. We've noticed that a lot of safety-related incidents for trucks are related to incorrect tire pressure. Incorrect tire pressure is one of the main reasons why there are incidents with trucks. So if you feedback the tire pressure to the driver, he can take that into account, and that actually saves when it comes off for incidents. So what we have in the service is that if you ride over a tire pressure sensor, you will get that information displayed in your car so you can act upon it. And there are a lot of additional sensor type of information coming available now, which we can incorporate within this service. So the idea is that all this data is now being fed into the truck. And we're going to show you a film of how this actually works. These are not just ideas. there are actually people driving around in the Netherlands with these kinds of services live. There are multiple vendors who are now selling additional applications on top of these services, so there's also a business model for it. And I'm going to give you an example in this small movie on how this looks from a driver's perspective.
We zijn druk. En we zijn druk in de weer om goederen snel en veilig op plaats van bestemming te krijgen. Waarbij we denken dat we dat allemaal zo goed en efficiënt mogelijk doen. Maar het kan toch nog slimmer. Tijden veranderen. Steeds meer bruikbare informatie komt naar ons toe. En als je daarmee werkt, biedt dat voordelen. Kosten worden lager. De veiligheid neemt toe en het is beter voor het milieu. Natuurlijk wil je alles weten. Maar onderweg informeren we je alleen als het er echt toe doet. Zoals een afwijking in de bandenspanning. Want een lage bandenspanning betekent een grotere kans op pech en een hoger brandstofverbruik. En mocht er toch iets aan de hand zijn met de bandenspanning, dan komt die informatie ook snel bij de juiste mensen terecht. Wanneer je met ons meedoet, krijg je soms een streepje voor. Dat scheelt brandstof en tijd. Daarnaast is het ook beter voor het milieu. Al zullen er altijd situaties zijn waarin het veiliger is als een ander prioriteit krijgt. Het mooie is dat we met alle data die dit oplevert nog meer slimme toepassingen kunnen ontwikkelen en gebruiken. Hierdoor ontvangen we nog betere informatie. Nou is het niet zo dat je onderweg niets meer hoeft te doen. Want we moeten wel alert blijven. Natuurlijk helpen we je daar ook mee. Op deze manier blijf je goed geïnformeerd en veilig onderweg. Ongeacht welke situatie er op je pad komt. Zo houden we de vaart erin. En als je last krijgt van hobbels onderweg, dan weten we die sneller dan ooit te traceren. En waar nodig, ondernemen we actie. Met z'n allen krijgen we zo verschillende situaties veel sneller in beeld. Omdat er dus ook data vanuit de trucks wordt verstuurd. En doordat we al die data op een veilige en afgesproken manier met elkaar uitwisselen, weten we ook precies wat voor invloed dat heeft voor de planning. We maken ons vanaf nu dus niet meer druk. We maken ons slim. Doe mee. Zo werken we samen aan slimme oplossingen voor de reis van vandaag en de wereld van morgen.
So this gives you an idea on how it looks from the driver side. An integrated set of services, given warnings on specific points in time, allowing them to concentrate much more on the driving task, but also make sure that when there are things like other routes they have to take, that it is something which is communicated within the truck itself. Now, at this moment, there are a number of commercial providers who provide these kinds of services. And if you go into the Google App Store, you can find at least 3 different applications who are built on top of this data. So what we do within SmartWays and Connected Transport Corridors is we make the data available using a standard interface, and it's then up to market parties to take that standard interface and build applications around it. And here you can find 2 of them, Truckmeister and Greenflow for Trucks, which are applications you can simply download, install on your phone, link it to your truck, and you will get these kinds of services. But if we look at the way we want to scale something like this, we really have to look at the architecture as well. You can imagine that using a specific app in a phone, in a truck, only goes so far. What we actually want is we want to integrate all these messages into the fleet management system on an on-trip situation, which means that these elements are not separate from your fleet management, but are integrated into your fleet management system. That is something which is not easy and requires quite a lot of market parties to work together to come up with these kinds of services. So as of now, we have 30 organizations who are using these kinds, but what we really want is to integrate it into the fleet management system. And I'm going to give you a little bit of an idea on the complexity of taking the next step of that integration. I'm going to show you an architectural picture. It will be the only one, so. And essentially, what we're looking at is how do we connect trucks to traffic light controllers? What are the different steps we need to take? And we want to do that in a standardized way. We don't want a specific fleet management system talking to a specific traffic light controller. No, we want all fleet management systems to connect to all traffic light controllers in the country. And for that we build a number of different steps. If we look at it from the right side, from the truck side, of course the truck is linked to their own fleet management system with existing technology, probably proprietary, and that is of course excellent. That is not something we're going to touch. So the idea is that we want to reuse the existing architecture fleet management systems now have when they link to their trucks. If you look at the middle element, the cloud service provider, that is an essentially new element which we have added into the architecture. The cloud service provider gets all the data from the traffic systems, gets access to the traffic light controllers and filters it out depending on the route and location of the truck. So the fleet management system sends a route and the location of the truck, and the cloud service provider then sends back all the information which is necessary giving that specific route. And the cloud service provider, we now have 4 of them in the Netherlands, is a commercial party. They can use, of course, this kinds of a basis for all kinds of additional services specific for their clients. It is the cloud service provider who does the priority request to traffic light controllers. So the fleet management system shows that the truck is approaching a traffic light. The fleet management system triggers a traffic light priority which goes to the cloud, and the cloud provider then goes to the urban data access platform. The urban data access platform is linked to all the traffic light controllers we have in the country. It's a single point of entry, and if you want to do something with a traffic light controller, there's a standardized way where you can access essentially all the traffic light controllers without having to bother with the different suppliers we have for traffic light controllers. So essentially the urban data access platform makes it possible for the cloud service provider to access all the traffic lights. And lastly, when it enters the urban data access platform, it goes to the traffic light controller and changes the color of the traffic light if it's possible. But it's very important, if you look at this architecture, it's all run using standard telecommunication connections. It uses 4G, which essentially means that messages going from the truck into the traffic light controller have to round trip through this architecture within 1 or 2 seconds, which is a very important element of latency. So one of the things we're now experimenting with is how fast can we get this. We know essentially that it works, and we have a number of fleet management systems who are now working on this architecture to incorporate it within their system and make it an integral part of the solution. Once that happens, you don't need additional hardware or an additional service to use this. It will be part of your existing fleet management system. And that is of course a very important part for the upscaling. We're looking at tens of thousands of trucks we want this service to use. We don't want that those trucks have to have additional hardware. We don't want that those trucks have a phone application. No, we want them to have these kinds of services completely integrated within their fleet management system. And that is also one of the reasons why we're looking at these elements, is how can we make something which is scalable and making reuse of the existing elements already in the truck. Now, very important is of course that we can say this is interesting for public organizations. Accessibility in the south of the Netherlands is very important, but what's in it for the actual logistic operator? So we're looking at a company who has 100 trucks. They are interested in these kinds of services, but what is in it then for them? Where are the cost savings? Where are the time savings? And that's one of the reasons why we built an elaborate simulation model where we can input a specific logistic pattern and then calculate what are the potential benefits if you would use these kinds of services. And here you can see two examples of the calculations done with the model. In the top one, we take an international transport business case, see how many trucks we have, what kind of services would you be using, and given your logistic pattern with these 15 vehicles, these are the fuel savings which are capable, the time savings, and the CO2 savings. And we can do exactly the same, for instance, for a business case which is much more regional oriented, for instance, a city distribution, count the number of traffic lights they pass and give them a first approximation on what's in it for them. And we see by using these kinds of elements and these kinds of models, we can translate this complex system into very simple benefits and earnings for logistic operators. And that is, of course, very important for scaling up. And we need to make this something which they can make money with for them to adopt it. Well, it gives you a bit of an idea on the things we're working on, specifically from Smartways, how we are accessing the different data stores we have, how we're combining it into services, and eventually making sure that the logistic operator earns money by using these services. And I would like to conclude by showing the different benefits we found in the program by using these kinds of data source. It's not easy to get all these different data together, but once you do and build them into services, we can see clear fuel cost savings in a lot of different organizations now using this as well. Very important, less emission and more sustainable transport. If we can reduce trucks from braking and accelerating, it has a lot of impact, for instance, on your zero emission policies within cities. We can see we can generate less traffic accidents, for instance, by giving them feedback on the tire pressure and making the driver aware of dangerous situations which occur during travel. It reduces travel time and gives a better accessibility. It's also something which is directly interesting for all kinds of cities. We can get alerts. And when we look at the whole of the logistic chain, if we have these kinds of services, we can predict time of arrival much more accurately. So we get better ETAs, we get better slot timing by using these kinds of data, which allow for better and tighter planning, which is very necessary now if we look at how in the south of the Netherlands logistic is being evolving. We need these kinds of different elements to make our planning much more concrete and tighter. And I think one of the last things which we found in these experiments is that the drivers find this very beneficial. In the Netherlands we have a big shortage of drivers, so the driver experience is becoming very important. And what we get back from drivers using these services is that, say, we have much more information. It relaxes the driving because we get only the information which is necessary for us. It gives us much more insight into traffic because we get these early warnings when necessary. So overall, the different drivers who are using the system are happy with using this. With that, I would like to end. I've given you an idea on how within Smartways we're using different strategies and approaches to put data to use to create more efficient logistics, to see how we can use things like connected transport corridors in a way that we can accelerate the adoption of these kinds of services. And lastly, how we focus on making it a viable business proposition for the logistic operators, otherwise they simply won't be using it.
Great.
Thanks.
Thank you. Thank you very much. Do we have any questions? Because I have a microphone for anyone. Any questions? I see someone pointing. Where? Oh, yeah. Thank you. Hi, could you introduce yourself as well? Thank you.
Hi, Sandra Rothbard. I work in city logistics as an urban planner. This is great. Thank you for your presentation. It's really exciting. Are you also working with municipalities themselves for the fleets that they own, even waste collection vehicles? Just if you have any insight onto, obviously very different than other types of logistics vehicles.
That is true, but for
Great.
instance,
Thank
the
you.
fact that the city is using it themselves also helps with adoption by other parties. And of course, a municipality themselves are also a logistic operator, specifically when it comes to waste removal, but all kinds of other services are interested for the municipality themselves. So municipality, specifically waste, is a very interesting area to try these kinds of services. And what we see is that a municipality might want to try it on their own waste fleet, for instance, first, and then start to look at other logistic operators within their municipality who might adopt this. And I think that municipalities have a very important part by showing off the possibilities by using these kinds of services themselves. And of course, if logistic operators can save money, municipalities can save money as well.
Great, thank you for your question and thanks for the answer. Anyone else? Feel free. Yes. Could you introduce yourself as well? Thank you.
Hi, this is Arne Ziele, and I'm here for Trimble Maps, and I've actually got two questions. One is regarding your last point on the better informed and relaxed drivers. What is your experience with the schooling that is needed for the, let's say, end user, the drivers, the dispatchers? Second question would be, when feeding back information of the trip, are there standardized formats? Yes, these would be my two.
Yeah, thank you.
Well, I think there's some training necessary, but given the fact that you have to have training anyway for introducing a fleet management system, this is only a relatively small part of it. So when you introduce a fleet management system within your organization, or when you start using transport management planning, there are courses you have to do, you have to train people. And this will be part of that. So what we see is that there is some load in the sense that you have to train with these new options, but it's much more in the sense that you get a new version of your fleet management system or a new version of your transport management system, and there's some education there necessary anyway. The second question is that there are not directly standard formats when it comes to feedback. We leave that in large part to the markets. But of course, when you look at driver feedback and driver coaching, you will get a lot of information from the truck which you can use for that. So it's pretty much up until to market parties by using the feedback which comes from the truck to see what they can do there. But to give you an example, a lot of the strip feedback also goes through the cloud service providers. And there are a number of cloud service providers thinking about building additional services on top of that information, where they can, for instance, give insight into the braking behavior in a certain region, or they can give insight into how different distribution patterns happen in a city, depending on, for instance, retail or building logistics. So there's a lot of possibility for commercial parties to build additional services on top of the data.
Thanks. Yeah, great. Anyone else? Feel free. We have time. No, great. Laurens, thank you. I'm going to see. Can you give me a hand? Thank you. Because otherwise I have to walk all the way around. Thank you very much. And your questions and your story is a nice bridge to our next presentation at 11:30 from Rijkswaterstaat. And Rijkswaterstaat is a Dutch road authority, and how they use data and how they feel from a more, from a government level, from a government point of view. So if you're interested, come back at 11:30 or just stay put. And may I have a round of applause once again for Laurens.
Thanks.
See you later. Enjoy the show here.